Hello, good evening, Matt Don. Thanks for the video. All right, the first thing I want to talk about is free will. I do not believe in free will or unfree will. I've said this before, just covering my bases here. We talk about free will. That's a term that talks about all the freedom in will. It doesn't absolutely have to mean this concept of free that's totally unrestrained. That concept of free doesn't apply to anything. Free anything. If you use that definition of free in any compound term, you're going to have something that is not real. Nothing is free in the totally unrestrained. So we're really talking about will power. And the discussion of free will is a discussion about if there could even be an influence by something called the will, if there can be any reality to this feeling we have that we're making choices. Okay. Now, in quantum mechanics is not about acausal events. I don't really understand where people get that. If a photon is flying through space and it comes in contact in the space of a particle, you know, it's an event. And the fact is that whatever happens is a result of that photon hitting there. It's not that there isn't a cause, it's that there's more than one possible result. It's not that it's acausal, it's that the idea that one cause leads to one result doesn't hold true. One cause can lead to multiple results. The particle can absorb that photon, it can reflect the photon, it can scatter the photon, it can just get skipped by the photon. Okay, and these are the results. Now, in terms of the rolling the dice, I didn't forget all those details at all, and I'm sure you could make a device that would master the odds a little bit. But I don't think you would probably have certainty, but you might, because there are certain things that are determinable sufficiently in the end. Um, but all those details that you went on to, the friction of the surface and stuff, those are all the deterministic aspects, right? So I can ignore those because all those deterministic aspects, however million there are of them, as you pointed out, they all add up to a deterministic result. We're focusing on the part that may be non-deterministic, all right? And that's the point. If you keep looking at the details of the dice, we know eventually you will get to the quantum level. Now, why do you think you'll be able to stop? When you're using this thought experiment of if we got all of the data, how would you think that you're going to stop at some level and not have to go to the quantum level? That's part of all the data. And we know for a fact that at the quantum level, the molecules in those dice don't even have particular locations. It doesn't have a particular shape. It has a set of possible shapes, okay, that coexist until it comes in contact and the shape is sort of committed by having contacted some other material. So, we know that when you look close enough, if you look at all the details, you'll get to non-deterministic details. Now, on patterns, and this idea that, the fact that patterns arise means it's determinism. No, it doesn't. And then I can demonstrate that with some simple logic by the fact that, and by the way, if I'm being too earnest, I mean, it's just because I liked the challenge you provided, okay, but I disagree with it. But the logic about that is simply that um, there's such a thing as an indeterministic pattern. Okay, stochastic and indeterministic patterns. That's a pattern, but it's indeterministic, so it's not deterministic. Therefore, not all patterns are deterministic. So it's not excuse me, it's not that patterns arise from determinism, it's the other way around. The appearance or illusion of determinism arises because the patterns sometimes match up such that you can determine and predetermine things. Okay? So that's why I think pattern is a more general term, because it includes the possibility of non-deterministic patterns. And it's nothing acausal. It's a new idea of a causal property. Okay, that one cause can lead to multiple events. Now that's true in quantum theory. And when you take any system that you want to take, like you were taking, and take a classical approach and look at it closer and closer and closer, eventually you get to the quantum level. So eventually you reach non-determinism. That's what I'm saying. Okay, cheers. Thanks.